आज का सेशन है Geometric Progression GP. Geometric progression is a sequence whose terms increase or decrease by a constant ratio, called the common ratio. A1, A2, A3, A4. AN, this is a series. Common ratio, R. We get R by dividing a term by its previous term. Here A2 is divided by A1, similarly A3 is divided by A2 or A4 is divided by A3 to get constant ratio. AR square, AR cube, AR to the power 4. AR to the power n minus 1, AR to the power n is GP where the first term is denoted by A and the common ratio by R, here. A is first term, AR is second term, AR square is third term. AR to the power n1 is nth term and this is n plus 1 th term. Hence, the nth term is given by n is equal to AR n1. Example 1, for the series to plus 6 plus 18 plus 54 plus. Find the 10th term. Solution. A is equal to 2. R is equal to 6 by 2 is equal to 3. AN is equal to AR to the power n minus 1. A10 is equal to 2 into 3 to the power 10 minus 1, that is 9. Hence, A10 is equal to 39,366. Example 2. The third term of a GP is 17. What is the product of first 5 terms of this GP? The correct answer is A. 175, B. 4976, C. 17 into 5, D. None of the above. Solution. Let A be the third term and third term is given as 17, therefore, A is equal to 17. Then the GP will be, we know A is third term, then fourth term will be AR and fifth term will be AR square. Now second term will be A by R and first term will be A divided by R square. The product of 5 terms. Multiply all these terms, here this R square and this R square get cancelled and this R and this R get cancelled and we get A5. We know A is equal to 17, therefore A5 is equal to 17 to the power 5 is the answer. Sum of first n terms. When R is greater than 1, this formula is used. When R is less than 1, this formula is used. Now, let's understand how this is derived. Proof. Let Sn be the sum of first nth terms of the given series. Sn is equal to A plus AR square plus AR cube plus AR to the power n minus 1, 1. Multiplying both sides by R, we get Rsn is equal to Ra plus AR square plus AR cube plus RAR to the power n minus 1, 2. Subtracting 2 from, we get Sn minus R. Sn is equal to A minus ARn. Or Sn, 1 minus R, is equal to A, 1 minus ARn. Sn is equal to A, 1 minus R to the power n, divided by 1 minus R. R is not equal to 1, 3. Changing the signs of the numerator and denominator, we can also write Sn is equal to A, R to the power n minus 1, divided by R1, R is not equal to 1, 4. It is convenient to use form 3 when R less 1 and form 4 when R is greater than 1. Note. Sum of infinite terms, when modulus of R is greater than 1. S infinity is not known. Sum of infinite terms, when modulus of R is less than 1. S infinity is equal to E by 1 minus R. Example 3, for the series 32 minus 16 plus 8 minus 4 plus 2. Find A, the 12th term. B, the sum of the first 7 terms. Solution. Given A is equal to 32, n is equal to 12, R is equal to A2 by A1, that is, minus 16, by 32 which is minus 1 by 2. Find the 12th term. Using an is equal to ar to the power n minus 1. A12 is equal to 32 minus 1 by 2 into 12 minus 1. A12 is equal to 32, 1 by 2 to the power 11. That is 32 into minus 1 by 2 to the power 11. This can be written as minus 1 to the power 11 by 2 to the power 11. 2 to the power 11 can be written as 2 to the power 5 multiplied by 2 to the power 6. Hence it cancels out. Hence answer is minus 1 by 64. A12 is equal to 1 by 64. B. Find the sum of the first 7 terms. Given A is equal to 32 and is equal to 7. AR is equal to minus 16 by 32 is equal to minus 1 by 2. Using this formula because R is greater than 1. Substituting the given values of A and an AR in the formula. Simplifying. We get answer 21.5. Example 4. Find the sum of the following series 1 by 5, minus 2 by 5 to the power 2 plus 4 by 5 to the power 3 minus 8 by 5 to the power 4 till infinity. Solution. The series is in G.P form because common ratio is constant. Common ratio R is equal to minus 2 by 5 to the power 2 divided by 1 by 5 is equal to minus 4 by 5 to the power 3 divided by 2 by 5 to the power 2 is equal to minus 8 by 5 to the power 4 divided by 1 by 5 to the power 3 is equal to minus 2 by 5 is equal to AR. Here A is equal to 1 by 5, AR is equal to minus 2 by 5 and is equal to infinity. We know, for sum of infinite term, when AR is less than 1 S infinity is equal to E by 1 minus A. Therefore, substituting the value of A and AR we get this. Simplifying. We get 1 by 7 answer. Example 5. Find A. Summation of 6 multiplied by 2 to the power R. R is from 0 to 10. B. Summation of 3 to the power R minus 20. R is equal to 1 to 12. Solution. Here A is equal to 6, R is 0 to 10, and is equal to number of terms is 0 to 10 that is 11. So, the series is 6 plus 12 plus 24 plus 48 plus. Common ratio AR is equal to 12 by 6 is equal to 2. Since R is greater than 1 we use this formula. Substituting the values of A, AR, and N, we get 12,282 answer. B. Summation of 3 to the power R minus 20, R is equal to 1 to 12. GP is 3 to the power 1 minus 20 plus 3 to the power 2 minus 20 plus 3 to the power 3 minus 20 plus 3 to the power 12 minus 20. We can split and write like this is equal to 3 to the power 1 plus 3 to the power 2 3 to the power 3 plus minus 20 plus 20 plus 20 plus 12 times. A is equal to 3, N is equal to 12. Common ratio R is equal to 3 to the power 2 minus 20, 3 to the power 1 minus 20 by adding 20 in numerator and denominator, plus 20 and minus 20 gets cancelled, both in numerator and denominator, we get 3 to the power 2 by 3 to the power 1, which is 9 by 3 is equal to 3. Since R is greater than 1 we use this formula. Substituting the values of A, AR, and N in this we get this, minus 20 is 12 times, so minus 20 into 12. Simplifying we get 7,97,160 minus 240 which is equal to 79690. We get 79690, the answer. Example 6.
The first three terms of a geometric progression are x, x plus 3, 4x. Find the two possible values for the common ratio. For each value, find these first three terms and the common ratio. Solution. The first three terms of a geometric progression are x, x plus 3, 4x. Dividing a term by the previous term, we get common ratio. Common ratio r is equal to plus 3 by is equal to 4 by plus 3 is equal to x plus 3 into x plus 3 is equal to 4x into x is equal to x square plus 6x plus 9 is equal to 4x square is equal to 3x square minus 6x minus 9 is equal to 0 is equal to x square minus 2x minus 3 is equal to 0 is equal to x minus 3 into x plus 1 is equal to 0 is equal to x is equal to 3 or x is equal to minus 1. If x is equal to 3, then first three terms will be 3, 6, 12 and common ratio r will be 6 by 3 is equal to 12 by 6 is equal to 2. If x is equal to minus 1, then first three terms will be minus 1, 2, minus 4 and common ratio r will be 2 by minus 1 is equal to minus 4 by 2 is equal to minus 2.
Example 7. Find the sum of the following series, 4 plus 44 plus 444 plus nth term. Solution. 4 plus 44 plus 444 plus nth term. Taking 4 common, we get is equal to 4, 1 plus 11 plus 1, 11 plus nth term. Divide and multiply by 9. Is equal to 4 by 9 multiplied by 9 plus 99 plus 9, 99 plus. Is equal to 4 by 9 multiplied by 9 can be written as 10 minus 1 plus 99 can be written as 100 minus 1. Plus 999 can be written as 1000 minus 1 plus. We can split and write as is equal to 4 by 9 multiplied by 10 plus 100 plus 100 plus minus 1 plus minus 1 plus minus 1 plus nth term. This is in GP form where a is equal to 10, r is equal to 10 and n is equal to n. Using this formula, since r is greater than 1, we get is equal to 4 by 9 multiplied by 10 plus 10 square plus 10 cube, 10 and 1, plus minus 1 n times. Is equal to 4 by 9 multiplied by 10 into 10 to the power n1 by 10 1 plus minus n, as n times minus 1 is minus n. Is equal to 4 by 9 multiplied by 10 to the power n plus 1, minus 10 minus n 10 plus 1 n, whole divided by 10 1, which is 9, simplifying we get is equal to 4 by 81 multiplied by 10 n plus 1 10 9 n. Example 8. $100 is invested into an account, earning 5% compound interest per annum at the start of every year. Find the amount in the account at the end of the 8th year. Solution. The amount in the account at the start of each year earns 5% interest. That is, the amount is increased by 5%. To increase an amount by 5%, multiply by 1.05. The amount in the account at the end of the first year is equal to 100 times 1.05. At the start of the second year is equal to 100 plus 100 times 1.05. At the end of the second year is equal to this amount times 1.05 is equal to 100 times 1.05 plus 100 times 1.05 square. At the start of the third year is equal to 100 plus above amount. The amount we now have at the end of the third year is equal to 100 times 1.05 plus 100 times 1.05 square plus 100 times 1.05 cube. With A is equal to 100 times 1.05 is equal to 105 and AR is equal to 1.05. We want the sum to 8 terms, that is N is equal to 8. Using this formula, since R is greater than 1, substituting the values, we get is equal to 1002.66. Hence, the amount in the account after 8 years is $1,002.66.
Example 9. If the value of a flat depreciated by 25% annually, what will be its estimated value at the end of 5 years if its present value is that 15 lakhs? Solution. A is equal to 15,000,000. The value of flat at the end of first, second, third, fourth and fifth years form AG.P with common ratio. R is equal to 100 to 25% is equal to 75% is equal to 0.75. The value at the end of fifth year is equal to the value at the beginning of sixth year. Here, the value at the beginning of first year, A is equal to 15,000,000 taka. So, the value at the beginning of sixth year is equal to AER to the power 6 to 1 is equal to AER to the power 5 is equal to 15 lakhs into 0.75 to the power 5 taka is equal to 15,000,000 times 0.373046 taka is equal to 355,957.03 taka. Therefore, the estimated value at the of fifth year is 355,957.03 taka.
Example 10. If the population of a town increases to 0.5% per year and the present population is 26,24,000, what will be the population in 3 years' time? What was it a year ago? Solution. Since the population increases by the percentage ratio 2.5%, it is a GP. The first term, present population, A is equal to 26,24,000. Common ratio, R is equal to 100 plus 2.5% is equal to 102.5% is equal to 102.5 100 is equal to 1.025. The population in 3 years will be equal to the population at the beginning of 4th year. We know that nth term is equal to AER to the power n minus 1. The population will be in 3 years is equal to AER to the power 4 minus 1. We know 4th term is equal to AER to the power 4 minus 1, which is equal to AER to the power 3. Is equal to 26,24,000 x 1.025 to the power 3 is equal to 2,82,55,761. Answer. The population of a year ago is equal to AER to the power 0 minus 1. Is equal to AER to the power minus 1. Is equal to 26,24,000 x 1.025 minus 1 is equal to 25,60,000. Answer.